Running ground wires in plenum ceilings presents specific challenges due to fire safety regulations and material restrictions. When standard wiring methods are not permissible, several alternative solutions can be considered. Firstly, using plenum-rated cable is a primary option. This involves purchasing THHN cable that is specifically designed with plenum-rated insulation, such as FBLP or FBLR. These cables are manufactured to meet stringent fire safety standards, ensuring that they do not contribute to the spread of flames or produce excessive smoke in the event of a fire. Secondly, another effective solution is to utilize plenum-rated raceway systems. This approach entails installing plenum-rated conduit or cable trays to enclose the ground wires. It is crucial to ensure that all fittings and boxes used in conjunction with the raceway system are also plenum-rated to maintain the integrity of the installation. This method provides a physical barrier, protecting the wires and containing any potential fire hazards. Thirdly, indirect routing can be employed to bypass the plenum space altogether. This involves running the ground wires through an adjacent non-plenum space, such as an attic or crawl space. When implementing this method, it is essential to use penetration fire barriers where the wires enter and exit the plenum ceiling to prevent the spread of fire or smoke between different areas of the building. Fourthly, an alternative to traditional master ground bars is the installation of grounding busbars throughout the ceiling. Grounding busbars provide multiple connection points for ground wires, distributing the grounding network more evenly. The ground wires are then connected to the busbars using plenum-rated cable to comply with safety regulations. Fifthly, another option involves enclosing the ground wires in a plenum-rated jacket. This can be achieved by using materials such as metallized polyester sleeves or flexible polyvinyl chloride conduit specifically designed for plenum use. To ensure a complete enclosure, heat shrink tubing or tape should be used to seal the ends of the jacket, preventing any exposure of non-plenum-rated materials. Sixthly, grounding plates can be installed throughout the ceiling to provide additional grounding points. These plates are typically made of conductive metal and are securely mounted to the building structure. The ground wires are then connected to the plates using plenum-rated cable, creating a comprehensive grounding network within the plenum space. When implementing any of these solutions, it is essential to consider several additional factors to ensure a safe and effective grounding system. Firstly, all connections must be made using compression connectors or other approved methods that provide a secure and reliable electrical connection. Secondly, after the installation is complete, it is crucial to test the continuity of the grounding system to verify that all components are properly connected and that the grounding path is continuous. This can be done using a multimeter or other testing equipment. Thirdly, it is imperative to consult with a local building code and fire inspector to ensure compliance with all specific requirements and regulations pertaining to plenum wiring. Building codes and fire safety standards can vary depending on the jurisdiction, so it is essential to obtain the necessary permits and approvals before commencing any work. Proper planning and execution are paramount when working with electrical systems in plenum spaces. By carefully considering the available options, adhering to safety regulations, and consulting with qualified professionals, a safe and effective grounding system can be achieved.